This is an introduction to angles on a coordinate plane. The angles in standard form over here shows you the x and y axes, and they have the angle degrees marked out for you. They have 0, and then straight up is going to be 90, right? This is perpendicular. And straight to the left is going to be 180. Straight down is 270. So each quarter is adding another 90. So when you get all the way around, it's going to be 360. Okay, so an angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. So that ray that's on the x-axis is called the initial side. So the initial side of this angle would be right there. The other ray is called the terminal side. So the terminal side is right there. Counterclockwise results in a positive angle measure, and clockwise results in a negative angle measure. And then one full rotation is 360 degrees. So when you're drawing angles in standard form, you draw them based on the 90, the 180, and the 270, and then 360. So you're just given a good estimate. So at 75 degrees, well, that's 15 degrees less than 90. So 90 would be straight up, right? So I'm not going to draw that high. I'm going to draw something like that. And then I'm going to draw the initial side over here. And so I'm going to say that's about 70 degrees. It's close enough. We're just estimating here. Negative 160 is going to go backwards. Right? You're going to start going down this way. Now, negative 180 would be all the way to the x-axis, but we're not going that far. We're just stopping at 160. That's 20 degrees less. So that's probably a little bit off, but something like that. So we'll just say that angle there is about negative 160. And then the 430 degree angle, well, that's more than 360, so you just subtract 360 from the 430 to figure out how much farther it will go. So it's going to go 70 degrees farther than all the way around. So it's going to go all the way around and then a little bit farther. And 70 degrees is 30 less than 90. So somewhere in there. And draw the little spiral that I did there. So that's showing me that it goes farther than one rotation around. And that's about 430 degrees. So radians and degrees. You probably noticed that your calculators have both modes on them. You have radian mode and degree mode. They're just different units of measuring the same thing. They're measuring angles. A radian, you can read this, a radian is a unit of angle measure based on arc length. So when the arc length is the same as the radius, that is 1 radian degree, or 1 radian angle. Okay, so remember the circumference of a circle is 2 pi r. It says 2 r pi, but I would usually say 2 pi r. So 360 degrees is 1 rotation, so it's going to equal 2 pi radians. Okay, 180 is half of 360. Right, so 180 is going to be 1 pi radians. It's going to be in this label, you can just put rad for radians. So if you want to convert from degrees to radians or radians to degrees, you have these two little formulas. Okay, and they're both based off of this up here, that 180 degrees is equal to 1 pi. So if you have degrees and you want to go to radians, here's the formula you use. And if you have radians, you want to go to degrees, it's just flipped around a little bit. Notice really the only difference is the fraction. Okay, so if you have degrees, you want the degrees, the 180 in the bottom. If you have radians, you want the radians in the bottom so that they will cancel each other out. right? Let's go look at a couple of these. So if we have 30 degrees and we want it to become radians, we take 30 and multiply it by pi over 180. Right, that's straight out of the formula there. Take the degrees times pi over 180. So this would be, that 30, we can call it over 1. We'd have 30 pi over 180. And then you just ignore the pi and you look at the 30 over 180 and you just simplify it. So I know that's going to reduce down to 1/6. So pi over 6 is how many radians that is. Okay, so with 150, just multiply that by pi over 180. So it's going to be 150 pi, oops, forgot the 0, over 180. And then I just simplify this. So I can lop off the zeros, 15 over 18, and then reduce it from there. 15 pi over 18, both be divided by 3. So I'm going to have 5/6 pi, or 5 pi over 6, whichever way you want to say it. And so the negative one is no different. It's just you're going to have a negative radian. So we have negative 220 times pi over 180. And then I'd have negative 220 pi over 180. And then I simplify from here. So you can think of that as 22 over 18. They can both be divided by 2. So negative 11 over 9 pi. And there we go. So if I want to go backwards and change them into degrees, I'm going to put the pi on the bottom and the 180 on the top. So I have multiplied by 180 over pi. You want to cancel out the pi's if you want to convert to degrees. So both of those pi's can cancel out. Right, and then I'm going to have 4 times 180 on the top. So that's going to be 720 over 3 on the bottom. So 720 divided by 3 is going to leave me with 240. So 240 degrees. So same thing with this, 5 pi times 36, or over 36. Multiply that by 180 over pi. Keep the pi on the bottom to cancel out the pi's. Those will cancel. You have 5 times 180. And that's going to give us 900 over 36. So if we divide 900 by 36, it's going to come out to 25. So 25 degrees. Last one here, 7 pi over 4 times that by 180 over pi. So the pi's can cancel. Multiply the 7 times 180, and you will get 1260. So 1260, divide that by 4, you're going to end up with 315. So there, the converting is pretty simple. You just have to make sure your fraction is going the right way. The 180 over pi or pi over 180, depending on which direction you're going. So moving on to the back side here, we're looking for coterminal angles. Coterminal angles are just angles that end in the same location. So if you look at the picture on the left-hand side here, the 90-degree angle obviously goes straight up and is the exact same ending point as negative 270 degrees. So they're coterminal. They have the same terminal side. So if I'm got 65 degrees and I want a coterminal angle, I just need to add or subtract 360 degrees from it, one rotation. So if I add 360, what do I get? Got 425. So that will be a positive coterminal angle. So give 2 coterminal angles for each given angle, one positive and one negative. Right, so that's our positive. So now to get a negative, I just take 65 and subtract one full rotation. So subtract 360, and it's going to leave us with negative 295. So there are two coterminal angles, one's positive and one's negative. So that's all you're doing. You're adding or subtracting one full rotation. So do the same thing with 540 there. Add or subtract one full rotation. You're going to notice you need to subtract 360 twice to get down to a negative. Now when you're dealing with radians, you're just adding and subtracting one full rotation again, which is 2 pi. So we're adding 2 pi to 13 pi over 18. Now when you add fractions, you need to make sure the denominators are the same. So I need to turn the 2 pi into 18ths. I need to cut each of those pies into 18 slices. So there's going to be 2 times 18 is going to be 36. So this is the same thing as 36 pi over 18. So I take 13 and plus 36, and that will give me 49. So I'm going to have 49 pi over 18. And if I could simplify it, I would, but I cannot simplify that one. So there it is. To get a negative, again, I do the same thing I was doing with the degrees. I'm just going to subtract by a full rotation. But again, I want it to be in 18ths. So I'm going to subtract 36 pi over 18 from 13. So 13 minus 36 is going to leave me with negative 23 pi over 18. So that's the idea there. You add and subtract 2 pi, or you add and subtract 360. Reference angles is the angle that's below or above the terminal side of an angle. So if you look over at the picture, there's the terminal side. So this reference angle is the angle that's below it with the x-axis. If the terminal angle was underneath the x-axis, then the reference angle would be above it. So they want us to find the sketch and find the reference angle for each angle. So 225 degrees is closer to 180 than it is to 360. So you want to take the 225 and subtract 180. And so that's going to tell us that it's 45 degrees. So if I subtract that 180, I get 45. And so that tells us that it's 45 degrees below 180. So I'm going to sketch it down here. This would be 225. The reference angle would be the angle below the x-axis. So that's going to be a 45 degree angle. Remember, I know that this angle here is 180, and this one here is 225. So if I take the difference between them, I'm going to be left with 45 degrees. So that's my reference angle, the difference between the x-axis and the terminal side of the angle. So if I'm looking at negative 310, that's going to go backwards, right? How far backwards is that going to go is the question. If I go 360 degrees backwards, I'm going to end up back where I started. Right? So I'm not going all the way. I'm going, well, if I add 360 degrees to that negative, I'm going to get 50 degrees, right? So I'm 50 degrees shy of going a full circle. So that's somewhere in there. It doesn't have to be perfect. So that's the negative 310 degree angle. So the reference angle would be right here. It's going to be 50. So how much less than a full rotation is that? It's going to be give you a reference angle. So if we're looking in radians, it's the same idea as degrees. You want to figure out how far of the around the circle you're going. So 2/3 pi. So 90 degrees would be straight up, and 180 would be all the straight across, straight left. And remember, 180 is equal to pi. So 90 is half of 180. So pi divided by 2, or half pi, is straight up. Now this is 2/3 pi. 2/3 is bigger than 1/2. Right? This would be 0.6 repeating the 2/3 would be 0.6 repeating, the 1/2 would be 0.5. So I know it's somewhere in here. It doesn't have to be perfect. So this is 2 pi over 3. The reference angle would be the angle below it, right? Between pi and 2/3 pi. So how much of a difference is that is the question. What's pi? Take away 2/3 pi. So if I take this pi and slice it into 3 slices, I'm going to have 3 pi over 3, right? Take away 2 of those slices, and I'm left with 1/3. Right, I'm left with 1 slice. So pi over 3 is the reference angle.